Okay, so some review. Take a look at that triangle on the board. There's the famous formula a squared plus b squared equals c squared that will help you to solve for x. Just take a second and remember how to do that. I'll reveal the answer in just a second. Give it a shot. Since we do so much with right triangles, of course, this comes up all the time. The Pythagorean theorem. All right. 2 squared is 4. 3 squared is 9. 9 and 4 make 13. And then how do you finish it? Square root of 13. Raise your hand if you had that one right. Okay, good. Try the next one. It's harder because it's not just add them together. Okay, so what you should be thinking is 3 squared plus x squared equals 6 squared. 9 plus x squared equals 36. Subtract the 9 from the 36. You got x squared equals 36, 27. And then x equals square root of 27. Raise your hand if you had that one right. Okay, good. What if I said you were wrong? You're wrong. You're stupid. No, you're stupid. How about if I made this into root 9 and root 3 and then said 3 root 3? Did anybody do that? Okay, just forewarned, you should do that. Don't just leave it as square root of 27. If the number happens to have a perfect square in it, that'll work, and you should reduce it as far as you can. You could lose a whole R3 based on not simplifying your answer all the way. Okay, all right. Convert 9.3 inches to feet. Well, 9.3 inches to feet, that's less than 1 foot, right? So what are you going to do? Let me finish this one first. What are you going to do? Simple, simple, really simple. What do you do? Divide by 12. Okay, and final answer? 0.775 feet. Now, stoichiometry, changing that over with 9.3 inches, if I want to change 9.3 inches into feet, I would multiply by a fact that has inches on the bottom. And what is that fact that has inches on the bottom? 12 inches is what? 1 foot, and now these cancel, and yeah, it's 9.3 divided by 12 that way is another way to say it. Okay? All right. Back to this thing, and I'm going to pause for a second. All right, so back to, let's move on. Here is a just a quick reminder of stuff that you need to know. We're going to be doing a lot with right triangles. We're going to be doing trig functions with a calculator. We've done some of this before. Some terminology you need to know. This angle right here is formed from this, which is called the initial side. And does anybody remember, as you swing it to, like, let's see if I can get the end to swing here. Come on, swing. Swing. Okay, it's not going to swing. I'll just let it get out of there then. If I were to swing it, you guys can see this like this. Okay? Then this angle ends with this side, which is called the what side? Somebody said it? Terminal. The terminal side. Thank you. This one's initial, and this one's term. The terminal side. Okay. Bringing that up because that's going to come up again. All right. These, you should know them, that sine has a upside down flip kind of deal, a reciprocal of cosecant. That's the way you write the word cosecant. We always are just going to use CSC. It's a shortcut for cosecant. Notice that sine has its cosine. It's sort of like pilot and co-pilot. Tangent has its cotangent, and secant has its cosecant. And they aren't lined up like that. What you got to remember is that sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. These are the reciprocal functions. They are flips of each other. All right, moving on. If I asked you to find all 6 of this, the one that would be really easy is tangent. Can you tell me tangent of theta? 7 over 11, because tangent is defined as, you can put these little helper things in here, opposite over adjacent. And the opposite side from it is 7. The adjacent side to it is 11. 7 over 11. There it is. So then what goes with that? And I can tell really easy. cotangent, and that's what? 11 over 7. But what are the other ones? They're all going to involve that number, which you don't know unless you use the quadratic, or sorry, not the quadratic, the Pythagorean theorem to find it. And we just talked about that, so I don't need to go through that again. But once you found that, let's say it was like the square root of 27 or whatever it was, then you'd be able to find your other ones, sine, cosine, because they're all going to need the hypotenuse. All right, next thing, just a little talking point. When I say this, how do you say it? I've had people say this in amazing ways. And it's sine of 30 equals 2/7. That's how you say it correctly. Sine of 30 equals 2/7. If it's this, it's not sine of 2/7. It's sine of what? Theta is 2/7. You're going to see that variable for theta a lot, or for the degrees. Okay. So next thing, we always notice have a degrees or a radians here, and then whatever these numbers are, they're the ones that flip if you are finding a reciprocal function. So like if I asked you to find, if I knew this fact that sine of 30 was 2/7, then what's cosecant of 30 equal to? 7/2. And notice that the degree didn't flip. It was this thing that flipped. Those are the sides, like the opposite and the hypotenuse, or the adjacent and the hypotenuse, or whatever. The sides are what flips, not the degrees. Still 30 degrees. All right, moving on. This one. I like these because it reminds you that you need to know the 30, 60, 90 and the 45, 45, 90 triangles. So, 30, 60, 90. I know the ratio is 1, 2, and what's this one? Square root of 3. Those need to be automatic. If you haven't memorized that yet, memorize it. You need to know that. How about on the 45, 45, 90? That's down here. 1, 1, and what? Square root of 2. Now, if you want to use x's, then I'd use x, x, and x times the square root of 2. Okay? Because there's two ways that you can memorize these. All right. Now, to go back, you had some problems like this. And they said, what's the answer without a calculator? And it seems like, how on earth could you possibly do that? Well, first of all, you got to know that pi over 6 is really some number of degrees. Would you please figure out for me what it is? Some of you are like, oh, that one's this. Don't say it, though. Write it down. Write it as sine of whatever degrees. Let's say I think it's 80 degrees. Write sine of 80. You'll need some paper to take some notes on, youngster. Back side of that thing is fine. Just keep writing. All right. Pi over 6. First thing I would be thinking is multiply by 180 over pi. And then this cancels this. And now I got my degrees. And that's 180 divided by 6, which is the same as, 6 goes into 180 how many times? Yeah, 30. So it's sine of 30 is what I'm really asking you. That does seem easier, doesn't it? Because you're used to degrees. And now you recognize, oh, it's in a 30, 60, 90 triangle. And then you go like this, 30, 60, 90, 1, 2, square root of 3. What's the sine of 30 now? Sine of this is opposite over hypotenuse 1/2. See how I did not need a calculator to do that? How did I know it was a 30, 60, 90? Well, because it said sine of 30, that means for sure the other angle has to be 60. Do you get that? If one of the angles, it's always a right triangle. Yes. Since it's always a right triangle, if this is 30, the other one's got to be 60 because they have to add up to 90. All right. Next kind. If we had this one, and it doesn't start with 1, 2, and the square root of 3, it starts with 10. Well, that's just 10 times as big, right? So then I could say it's 10, 20, and be careful on this one, 10 roots of 3. Everything got multiplied by 10, including that last thing. All right? Here's the one that stumps a lot of people, though. And some people just like, oh, the answer is this. How long is that side? It's not just 2. Nope. All right. Here's how you do it. Everybody, write this one down since nobody in the room is doing it right. Write that one down. Now, you got to set up a helper triangle. I strongly recommend the helper triangle. The helper triangle is your 30, 60, 90 in the same orientation, like make it look kind of the same except smaller. And 30, 60, 90, and you write down the ones with the X's in them. No, actually, don't even do that. I do this kind of 1, 2 in the square root of 3. It's faster, and it'll work fine. Now, why am I setting up that helper triangle? Because now I can say this one is to this one as this one is to this one. And it's a ratio, it's a proportion. 12 is to square root of 3 as n, I'm going to use that for my question mark, is to 1. And what's n divided by 1? N. So n is equal to what? 12 over square root of 3. All right, it's easy when I do it. Figure it out if n is there. We can use the same helper triangle. Mr. B, tell me what you're setting up back there. Twelve is to square root of 3 as is to what? Good. So really then, I just have to multiply both sides by 2 and I'll have n alone, right? So if I times by 2, you might realize that, oh, well, crap, I could have got that answer way easier. Because wasn't this other side 12 over the square root of 3? And don't you remember that this is 2 times as big as that one is? Remember that? So we could have done that just from that. That would have been even easier. Okay, but it either way works. All right, so one more thing. Let's say that we had a triangle with a 30, 60, 90, and let's say that this side here is 7. Tell me how long that side is. First, set up your helper triangle. Then set up your little proportion. And you'll have it. Helper triangle. Across from the 30 is the 1, and then the 2, and then the square root of 3. Instead of question mark, maybe I should call this n. And then I go, you know, you can start with the n if you want. If I wanted to do that, I'd say n is to what? 2 as 7 is to square root of 3. All right, so then to solve to get n alone, I times by 2. Times by 2 here. Times by 2 here. This cancels. There's my answer. Raise your hand if you had it right. Okay, good. Next thing, let's go on to some of our new stuff. So here's an application question, and I don't think we even have to do one this hard today, but I'm going to get you ready. You know how I try to get you ready ahead of time before we hit the hard stuff? So when you hit the hard stuff, it doesn't feel that hard. All right, and what we just were doing there was reviewing. I like to review a lot too. So this one, the hard part is not the trig. The hard part is drawing the picture right. Draw and label a triangle picture that matches this situation. I'm going to hit pause while you do that. All right, so here's what your picture should have looked like. Here's the tower. Now, some of you guys went to the right with your triangle. Some of you went to the left. It really doesn't matter. I'm going to go this way, and that's the ground. And then there's the wire. And now I have to be a little more careful on this part because the wire forms a 75-degree angle with the ground. So the wire and the ground together, not this one, that's a 90 logically. Tower stands straight up and down. The wire and the ground, so that's down here where the wire meets the ground is a 75. Raise your hand if you're right so far. Okay, good. Now one more number do I need? 55, and it goes down here. 55 along the ground. The distance from the base of the tower. It doesn't say the height of the tower. That's the point. How tall is the tower? So I call this x. And now you can use trig. Go ahead, see if you can do it. You have everything you need. You know the trig. You know how to type in tangent or whatever function you're going to use. Try it. So which function are you using? Sine, cosine, tangent? Tangent. So you use tangent of a degree. 75 makes sense to me. You'd have to use the 1 degree we have. I guess we could have gone from the other side and said, what would that be, 25? 70, no, 15? I could have used this 15 up here if I wanted. All right, tangent of 75. Tangent is TOA, opposite over adjacent. Opposite, adjacent, x over 55. So if I find tangent of 75 times it by 55, I'll have my answer. And Mr. BC in the back. About 205 feet. Now, does that make sense for a tower? It's pretty tall, but it seems somewhat reasonable. Okay. And if this is 55 feet out from the base of the tower, that seems reasonable that could be 200 feet. So, yeah, that sounds about right. Just double check your answers to make sure they make sense. All right. See if you can draw this one. It turns out to be a right triangle. Yes, sir. Let me show you something. Look under mode. Oh, you have it in degrees. I thought you were going to be in radians. All right, so then I go back to your screen and see what you did. Ah, it wasn't sine. It was tangent. That's the problem. Okay, so you're drawing a little picture. You got a river. Hopefully you've drawn a river. Make it a squiggly line or something. And then you have you. There's you. You're the little blotch there. This hiking towards the river thing reminded me of The Gray. I watched it this weekend. I like that movie. You have to like survival kind of stuff, but I like survival kind of movies, so that's a good movie. Yeah, don't tell the ending, but yeah, it left you with questions at the end, but it wasn't a terrible ending. What? No, no, dang it! He said they tell you at the end of the movie, at the end of the credits, what actually happens. Dang it! How am I supposed to? No, nobody told me that. Everybody else was walking out. I know some of the movies there's like a wait till the very, very end. You know, I've heard that before, but I didn't know that about this one. Doggone it! Who actually like waits? Now what am I gonna do? I guess it's gonna be out on DVD in not too long because it's at the cheap theaters. Is it? Ooh. Okay. All right. So now you say 200 yards to the river. Well, the only way you would measure that logically is to measure straight to the river. Therefore, you're setting up a right triangle, right? Okay, and then this was 200, and then from there, say you don't walk that way, though. You go 400 yards, which means this line here, 400 yards to the river. And now it's really important to figure out what angle they want. They want the acute angle. That means it can't be the bigger angle. It has to be the small one. Between this path and the river's edge. This path and the river's edge. That's the angle they wanted, not the other one. Okay, and then you're going to say sine, cosine, or tangent. Well, this one I'd probably use opposite and hypotenuse. That would be sine equals 200 over 400. That happens to work out to be 1/2, and I have this one memorized, but you don't even have to have it memorized. You just have to know, how do you get sine out of there? What do you do to both sides? Inverse sine. You do inverse sine on this side and inverse sine on this side, and that cancels that. Theta equals inverse sine of 1/2. Dirty. I do have that one memorized. Sine of 30 is 1/2, so I knew it was 30. All right, so if that's 30 degrees right there, if they had asked for it in radians, could you see that being a twist on the test? Be sure to give your answer in radians. And some kids to go all that work, get the answer of 30 and get it wrong, because they didn't finish by multiplying by pi over 180, and that would be your answer if you wanted it in radians. And that would be pi over 6. Because once you reduce the 30 over the 180, so it would be pi over 6. All right. One last thing. One of the sections on your book, homework, has got some easy problems that are very easy if you know how to do them. If they ask you to do this on the calculator, you should just say, thank you for giving me such an easy problem. You just type in sine 70, done. Okay, but what happens if they ask you to do cosecant of 70? Well, there's no button on the calculator for cosecant. But you know that it's flipped, right? So instead of doing cosecant of 70, you should do what? The sine of 70. Find out that answer. Let's say it's like 0.93 or something. And then what do you do to the answer? Flip it. You don't flip the 70, you flip the answer. So the answer would be 1 over whatever that is. Okay? Nope, won't work. Very common mistake. You know what? Let's prove it. Okay? So right now, just take sine of 70. Figure out what that is for me. Would you find sine of 70 for me? 0.93? Did I have that right? What just happened there? I either can do trig in my head or that's freaky. I did not do this example last hour, so I don't know what's happening. Okay, anyway. So then, what I really wanted was cosecant, which is cosecant of 70 would have to be 1 over 0.93. So take your calculator, take 1 divided by, and if you go 1 divided by previous answer, do you know where the previous answer button is? It's right above the enter key. 1 divided by previous answer, and you got what? All right, so what did I just figure out? I just figured out that the cosecant of 70 is 1.06. Now, try doing inverse sine of 70 and see what you get. It comes a pair. Therefore, it doesn't work. Okay? So this way it works. If it says error, you're doing something wrong. Okay. All right. So I think that's it. Okay, one last thing. The homework for this is page 366. Problems 29 through 58.